Hi everyone. Let's learn the hybridization in coordination. First thing we should know whether the ligand is weak ligand or a strong ligand. So over here, suppose if it's a weak ligand, it cannot pair up electrons. And if it's a strong ligand, it pair up electrons. So with that, you can fill the electrons in the orbitals. So weak ligands are fluoride ion, chloride ion, hydroxide ion, water. These are all weak ligands. Strong ligands, ammonia, cyanide ion, CO, NO2. These are all strong ligands. Okay, let's see how to find the hybridization using VBT, valency bond theory. So over here we have hexafluorido cobaltate ion, right? Why cobaltate? Because it is 3 minus negative. So CO plus 6 fluorine is equal to minus 3 because it is 3 minus. So cobalt considered as X plus 6 into minus 1, which is minus 6, is equal to minus 3. By rearranging this cobalt, you get plus 3. So plus 3 is the valency. When you find the oxidation state, right? So now you can write the electronic configuration. So cobalt's atomic number 27. So the electronic configuration is argon 3d7 4s2, 18 electrons with argon and remaining 9 electrons over here in 3d7 and 4s2, right? Yeah, it's not necessary to mention. If you can write this because we are going to show here. That's why. So cobalt 3 plus 3 is the oxidation number. So I have to remove 2 electrons over here. So 2 electrons from S2, 1 electron from D7. So which over here it becomes 3D6. 4 is 0, right? So over here 3d6 we showed, but what we have seen, fluorine is a weak ligand. Since it is a weak ligand, so over here the electrons does not pair up. So when it does not pair up, all 6 fluoride, because we they mentioned F6, so hexafluorido, which means all 6 fluoride ion will each donate one pair of electron to these 6 boxes. So which means 1s, 3 in 4p and 2 in 4d, which means the hybridization is sp3d2, sp3d2 hybridization. And if you see the structure, it's in 4 fluorides and 4 corners, and then 1 up, 1 down. So 8 sides are there. So it is octahedral. And the magnetic nature, since it is unpaired, it is paramagnetic. It has unpaired electrons. So unpaired electrons are there in 3D. So it is paramagnetic. And since it is paramagnetic, it is a outer orbital complex. If it's a outer orbital complex, high spin complex also, right? If it's inner orbital complex, outer orbital, why we say outer orbital complex? Since it is paramagnetic, since ligands are weak ligand, what happens here? It will not enter into D, right? If it enter, if the electrons, or if you fill in B, then we can say inner orbital complex. So now it is outer orbital complex, right? Okay, let's see one more example. Over here again, the central metal ion is cobalt, the ligand is amine, AMMINE, hexaamine, cobalt, not cobaltate. Why? Because there is 3 plus. So again, find the oxidation number, CO, X plus 6 into the oxidation number of amine. Okay. So over here, ammonia is a compound. Sum of oxidation number will be 0. So 6 into 0, 0. So X plus 0 is equal to plus 3, which means cobalt plus 3. Right? Okay. So now again, same way electronic configuration we have to write for cobalt and cobalt ion, and then fill the electrons. Now we know amine is a amine, AMMINE, right? Amine is a strong ligand, so it push the electron over here. So it is the inner orbital complex. You can fill the electrons in d orbital itself. That means six amine, one pair of electron here, two, three, four, five, six. So which will D2, two pair in D, one in S, and three in P. So D2sp3 hybridization, right? So the geometry octahedral over here similar like the previous one, and magnetic nature is diamagnetic since there is no unpaired electron in it, and it is inner orbital complex since it entered into d orbital itself, since it is inner orbital low spin. Hope you understood. Thank you. Bye bye.